Hi, I want to give you a quick overview of what a relational database management system looks like and what databases themselves are like. This is Postgres SQL, which is what we're going to be using for the first couple of databases. It's free, it's open source, but it's very powerful. This is what we're seeing as pgAdmin. You can see up here, which is a client. One of the things that I want to mention, so this is a client. That means it connects to the server. The server, the database server, runs in the background. This is true on a Mac, it's true on a PC, and it's true in Linux. It always runs in the background. pgAdmin connects to the service to provide a graphical front end. You could delete pgAdmin and it would have no effect on the database itself. And other software can be used to connect to the database as well. I'll show you just one real quickly. This is one you probably don't want to use much, but it can be useful. This is a command line. I've gone to the Postgres folder, server 12 bin. I'm going to be pgSQL, which is a command line client. I'm going to give it a user, which will be Postgres, which is the default user for Postgres. I'm also going to tell it to do a database, which will be community assist pg. Oh, I spelled it wrong. I can fix that by coming back. It's just pg. It's just pSQL. So I'll go to the end. I have to find my end button. Why do I not see my end button? Oh well, I'll just do it this way. Okay, so my user for Postgres is p@ssw0rd1. And now I'm in Community Assist, and I'm going to do a little bit of SQL. I'm going to select everything from the table grant type. It ends with a semicolon, and I do that, and it gives me everything from grant type. So this is another client that you can use. I don't advise it necessarily because it's a real pain. You have to type everything exactly right all the time. All right, so a database management program consists of managing a lot of database objects. So I have 3 servers. You're unlikely to have 3 servers. You'll probably just have the one, PostgreSQL 12. When I open that, it opens up. I'm going to close that. You have databases, you have logging, group roles, you have table spaces. Table spaces are ways of distributing a database across multiple disks. We're not going to worry about that. You probably do not have PG agent jobs. It's a feature that I added. We will play a little bit with login and group roles eventually. So let's look at the databases. And I'm going to close that up and close that up. So we have a list of all the different databases. Again, you probably will only have Postgres initially. Right? That'll be your first database and your only database initially. I'm going to go to the Community Assist PG. We just looked at that in the command line. And I'm going to look, we got casts, we can ignore that. Catalogs are for the meta information. Everything in a relational database is stored in tables, even information about tables. And if you look at these, it has several different tables that describe the other objects in the relational database. It has, you can find all of the columns and all of the coalitions and all of the indexes and etc. So we're not going to do much with that, but that's how you find out information about the database. You can actually query it in the same way that you query the tables themselves. So I'm going to close that up just so it doesn't take up so much room. And I'm going to go down to schemas. And you will only have the public schema. And in the public schema, you will find tables. And there it will list all of the different tables. So let's take a look at the person table. I'm going to right click on that, and I'm going to say view data, and we'll view all the rows. So one of the things it does is it shows you what the SQL would be to call that table. And then down here it has the actual table. Notice it consists of columns, right, across there, and there is person last name, person first name, person email, person primary phone, person date added. There's a whether they want to receive an announcement or not, and most importantly, there's this key column, right? The key column, it's a number that uniquely identifies each person. So Lynn Kendall is person number 1. Linda Cooper is person number 2. That's really important because, and I'm going to use this to write. Well, actually, I don't. So I'm going to go up to the top of this, of the database, and I'm going to add a query tool. And I am going to select star from donor. SQL, which we'll talk more about later, is not case sensitive, and it's actually not donor, it's donation. It is sensitive to spelling. This is the asterisk means select everything. If you want to select individual columns, you can. This is the run key. And when you look down here, you can see the different donations. Now, each donation has a key. And they're not necessarily in order. They're in the order they were last entered or last modified. So, this is the person key, all right? The person key relates to the person table. This is the person 130 with the key 133 is the person that made this donation of $500. This is the date that they donated it, and this is a universal unique identifier that identifies it. That is a mark that they can use for to retrieve it or whatever. So one of the things about databases is that they consist of data with tables. The person is only entered in one place. They're only entered in the person table. Forever after, they are referred to only by their person key or their person number. It could be a person ID. So you can always go back to person and find out who that person was. But we don't repeat anything about the person except their ID. This is called a foreign key. And if I wanted to, this is something we won't do for a while, but I could let's do, select person first name, person last name, donation amount, donation date, from person, and I'm going to join it with donation, and I'm going to say on person key equals donation person key. So this is just to show you that it's possible. You can join the information from the two tables. So, and if I wanted to, I could also just look at that first one where person key or person key equals 133. So we'll only look at the one person. So Lynn Mullins donated $500 on that date. Okay, so tables can be brought back together, but they are they're separated. The person information is in the person table. The donation information is in the donation table. Let's just do a quick select star from employee. So when we look at this, we see an employee key and we see a person key, right? There's nothing in this table that is humanly readable. You would have to go look up everything in the original tables. The person key, you'd have to go look up the person. There's another table where we do employee position. Which tells what positions each employee holds. And this is again a table that is not particularly humanly readable. There is the employee position key, there's the employee key, and there's the position key. It's all it's all just numbers. You'd all have to look it up. So a couple of other little things before I go on about this. So some tables are not readily readable by humans. Again, like this, they're just numbers, and that's okay. The point is not to repeat anything. Data is only entered in one place, one time. And the only repetition that is allowed is to repeat the primary key in another table as a foreign key. So we'll talk about that in just a bit in another video about primary keys and foreign keys. A couple of other things I want to make. Relational databases are complicated and they're designed for computers to process, not necessarily for humans. In real life, anybody that, like a charity that wanted to use this, would probably not do a lot of work directly on the database. They would have a website that talks to the database, that pulls up the information they want to see in the way that they want to see it. The back end is mostly for the database developers and maybe for an analyst, a data analyst that's working on the data. I think that is enough to give you a sense of what a database looks like. Again, a database is basically a series of tables. The tables relate to each other by means of keys and foreign keys. That is the gist of and this is true of any relational database. They are all structured the same. The front ends could look very different, but the underlying structure of the data will always be the same. All right.